We're going to learn how to solve compound inequalities. So this is an example of an OR problem. So one or the other thing or both of them are true. So the first thing we're going to do is we're just going to solve both pieces. So we'll get rid of our 3. Negative 2x is less than negative 12. We divide by a negative 2. Now, because I divided both sides by a negative 2, I have to remember to flip my inequality so it was less than became greater than 6, 4, get rid of our 1. Negative 3x is greater than or equal to negative 9. We divide by a negative 3. Since we have divided both sides by a negative number, we're going to flip our inequality. And so now let's draw our graph. We have, let's put 0 down here, 1, 2, 3, 4, 5, 6. We have x is greater than 6, so we're going to have an open circle on 6 because it's greater than, not equal to. Arrow to the right. We have x is less than or equal to 3, closed circle, and it's negative 10 is less than 3, so we're going to draw our arrow towards that direction. If I wanted to go ahead and give set builder, I'd have x such that x is less than or equal to 3 or x is greater than 6. And if I had interval, it would be soft parentheses, negative infinity to 3, hard, bracket because it's colored in, union, soft parentheses around 6 because it's not colored in, it's not equal to, all the way to infinity. So that's how you do an OR problem. Now let's skip to an AND. I wrote this in colors because I think it helps us see what we're doing. Basically, they're saying that this goes with, it satisfies both of these inequalities. So what we're going to do is we're going to rewrite that problem, and we're going to rewrite this problem. So let's go ahead and do that. We have 4x minus 2 is less than negative 10 minus 4x. And it also has to satisfy negative 10 minus 4x less than 4 minus 3x. Notice that the center section went, oops, I'm trying to look at the camera instead of look at my paper. This went with both things. Now we're just going to solve both of those little problems. So I'm going to add 4x to both sides. And I end up with 8x minus 2 is less than negative 10. Add R2. We get 8x is less than negative 8. Divide by a positive number. Since we divide by a positive number, we have x. We do not flip the sign. Oops, that was a positive 8. And so we get negative 1. And we're going to do the same thing over here. We're going to, let's add our 3x to both sides. So I have negative 10 minus 1x less than 4. I'm going to add my 10. Get negative 1x less than 14. And I'm going to divide by negative 1, which causes me to flip my inequality. And so this is an and in between. I think that it helps very much if you go ahead and draw a graph. And so put 0 here, get negative 1, all the way out here. That's not really equally spaced, but now let's do, we've got our green one, which says x is greater than negative 14, so 10 is greater than negative 14. So it's all the numbers, all my green numbers are everything this direction. Now all my blue numbers are less than 1, or negative 1, my bad. And so it's going to be an open circle as well. And the blue numbers are going to be everything this direction. Now, the answer to this question is the and. What works for both of them? Well, the things that work for both of them is everything between negative 14 and negative 1. That works for both of them. So when we go ahead and we write our set builder, this is our negative 14, negative 1. Set builder, we're going to throw the x in the middle. It's always less, less. We don't underline or put the equal to because they're not colored in. So we would have a curly brace, x, such that that it falls between those two numbers. If I wanted to do interval, it's going to be negative 14 is the smallest, negative 1 is the largest, and I need soft brackets around both because they're not colored in. And that's how you do an int.